So you have to know, this would be study sheet entry for sure, okay? On page 3 for exponential. That is a definite must-have entry, okay? And so this A value right here, okay, that number that's in front of the base, which has an exponent to it, gives you the y-intercept. So just by looking at that, you need to figure out the y-intercept. Now, on the test yesterday, I noticed that some of you are typing in everything to make sure you get it right. It's very time consuming, especially if it's a multiple choice scenario or a matching scenario. I would expect you to kind of just know this is kind of how it behaves. Absolutely, on the exam, you're going to have enough time to do that if you want to type everything in. But on tests, you probably won't always have enough time to do that, but just be careful. So this is your exponential. And then this B here, that determines whether the graph will be increasing or decreasing. So I don't know if you want this on your study sheet, if you want the whole graph, but increasing, you will always have something like this happening. Like it'll increase from left to right. Decreasing, it'll always go this way. But there's one more thing. There's what we call the asymptote. And so I'm going to use a red pen for this. Or should I use, I'm going to use a highlighter instead. I talked about the fact, hopefully you heard me say that exponentials will never cross the x-axis. They just never will. Okay? So this one here, I'm going to go along the x-axis. And I'm just going to make a dashed line there, like that. Please add that to your notes. So even though it looks like the graph is touching my x-axis, it actually never is. If you zoom in, I don't know if I showed you on Desmos, like if you zoom in, it just never will. It will be closer and closer. It will get infinitely closer, but never touching. So this is called the horizontal asymptote. Okay. So just so you don't forget, you can use this as a swear word. What a pain in the asymptote you are, right? And then be like, oh, yeah, I won't forget that word. So that just means it's like that imaginary line that tells us that this graph is just never going to cross it. Never crosses it, right? Okay, never crosses this one. So on your study sheet, I would most definitely include that because the province could ask you which of these functions has a horizontal asymptote, right? And you look through it's like you're going to see a bunch of polynomials, x cubed, x squared, x, those are linear, those don't have asymptotes, but when you get to this one, how do you know this is an exponential? The variable x is as an exponent, right? That's when you know this is a specific case of the exponential. You cannot miss it. You cannot miss it. That's like a dead giveaway, right? That the x is the exponent, right? X is the exponent. Oops, you can't see that, sorry. X is the exponent, so that is why this is called an exponential. Okay. And I do think that you should definitely have that if b is greater than 1, it's an increasing function. You have this from left to right. If b is between 0 and 1, it is going to be decreasing. So I'm really focusing, like I'm trying to fit everything into this box here so that you can transfer this to your study sheet and be okay answering. Okay. So if you want an example, 1.3 would be an exponential. An example here would be 0.4 or something. Something that's between 0 and 1 would make it decreasing. Okay. All right, let's keep going. I would love the end behavior to also be on there, and the domain and range, but you're just going to have to, let me try this. I'm going to try something here, just under this graph, under this box. End behavior, always, what do you think? It always goes from Q2 to Q1, always. It starts here, Q2 to Q1. Does it matter, Mr. Dirksen, if I say Q1 to Q2? It doesn't matter. I tend to go from left to right. I read the graph from left to right. That's why it's Q2 to Q2. So that's always the case. You don't have to guess. And there's one more thing. Domain and range. Let's do the domain and range right under here, because it is the same. Domain is going to be all real numbers in set notation, or negative infinity to positive infinity. The range is going to be a little different. Okay, this is where what you've seen so far is going to be different. It's going to be y is greater than 0 always. Not equal to. You notice that there's no y is greater than or equal to 0? It's not equal to, because it never, like this will never get to a point where y is equal to 0. If it does, it's not an exponential function. Okay? So either this, or you can go 0 round bracket. I'm going to use a red pen for that, because this one is new to you. You've never had to put an actual number with a round bracket. So it goes from 0 all the way to positive infinity. So no square bracket there, because then you're saying it could be 0. But it's not. Okay, so I would have this, all of this in one entry in my study sheet. This, of course, is a no context, right? No context. No word problem. The domain and range will change once there's a word problem. Okay? So if x is, the x-axis is time and y is the population in a little town, then obviously we wouldn't go negative, right? We would start right here and go up. So let's go to page 6. I did this on the video. I just wanted to, I almost want you to be able to look at these and without even looking at the graph, be able to picture the graph. That would be ideal, and I'm going to maybe give you like quick ACs like that, just mental maths almost, where you don't even have a calculator. And so you look at that, A is greater than 1. So this is going to, we know it's going to do something like this. Okay. What's my y-intercept in this case? 0, 3. Y-intercept is 0, 3, just by looking at that A value. Right? Wait a minute. Am I getting something wrong here? I think I am. My bad. A has nothing to do with increasing or decreasing, right? That's where your study sheet entry is going to help you. My bad. What do we look for increasing or decreasing? We're looking for the value of B. So that's where I made a mistake in this case. If I go back here, I'm just going to say that that is A though, and that is B. Okay. A and B like that. Y-intercept is 0, 3, and this is decreasing. Why? Because B is between 0 and 1. So when you picture, remember it's never going to cross the x-axis, it's going to decrease from left to right like that. So you should be able to just look at that and picture and see what's going to happen, and it's going to go through 0, 3, guaranteed. And so that's something that I would want you to be able to figure out at this point. So let's see here. Just look up. Increasing or decreasing, this one? Increasing, right? Because B is bigger than 1. Increasing or decreasing? Decreasing, right? Because it's between 0 and 1. Increasing or decreasing? Increasing because B is bigger than 1. All right. What if you have something, because you might encounter that. What if you just have something like that? I don't know if one of the examples had it in the lesson. What's A in this case? A is technically 1. Okay, so you kind of have to imagine that if the brackets aren't there, then A is equal to 1 there, B is equal to 4. It's still increasing, but just keep that in mind. Okay, so let's go to page 7. This is where the lesson probably got into this. I asked you to stop after page 6. Okay. A and B cannot be negative in this course. You don't have to worry about that. You're never going to be getting something like that. But if you ever do a regression, you get a negative, you're in trouble. Okay. So when it comes to word problems, okay, I'm going to actually start a new